All right, chemistry class, Mr. Mellinger, and we're now on day 56. This is Wednesday, May the 13th, and our topic is going to be 3-step stoichiometry. It's exactly the same thing that we've done on Monday and Tuesday, except we're now going to add a third step to it. So what you have down here is the grams area, and this represents you. This is something that we can measure in the real world as grams because we have scales that measure grams. But what we need to do is convert those grams into moles, which is numbers of molecules, because chemical equations are interested in matching up molecules. So the example I gave is if I want to have a group of 2 girls and 1 boy, and I want to have groups of 3 with 2 girls and 1 boy, I just care how many girls I have and how many boys I have. So every group is 2 girls, 1 boy. Next group, 2 girls, 1 boy. I don't care if the boy weighs 100 pounds or 500 pounds, or if the girls weigh 50 pounds or 100 pounds. It doesn't matter what they weigh or how big they are, how much space they take up. I just want to have a number, 2 girls for every 1 boy. And that's what a chemical equation is doing. I like to write the coefficient even when it's a 1. So it's saying that for every 3 oxygen molecules, we need 1 molecule of C2H4. So it's simply counting number of molecules, or as we've said, we really think of these as moles. Big baskets of 6.022 times 10 to the 23rd molecules. So fortunately, there's a translator that gets us from grams, which we can measure on a scale, into the world of moles, which the chemical equation speaks in. So first thing I need to do is fill in my molar mass conversions, and we did those yesterday. So 2 carbon is 2 times 12. If you look at the periodic table, and that's 24, plus 4 more hydrogen, that's 4 times 1 for hydrogen. Again, that's off the periodic table. So that's a total of 28 grams. All right, and O2. Each oxygen is 16 from the periodic table, so 2 of them is 32. You don't count this. This is saying that there's 3 moles of oxygen, but your molar mass conversion is 1 mole of oxygen. It's how many grams is each mole of oxygen, so don't let that confuse you. Okay, carbon dioxide. 1 carbon is 12. Each oxygen is 16, so that's 16 plus 12. That's going to give you 44 grams for 1 mole of carbon dioxide. And finally, water. Oxygen is 16. Hydrogen is 1, hydrogen is 1. If you have 2 of them, that's a total of 18. So that's your molar mass for that, okay? All right, so let's go ahead and get started. These are done the same way. It's just there's going to be one more step, and you'll see that in a second. So how many grams of H2O? So we're down here in the grams row, and we're over here in the H2O column, and it wants to know how many. So that's where our question mark goes. Will be produced by 5.2 grams of CH4. So again, we're down here in the grams row, and we need CH4. So it's 5.2 grams of CH4. There's simply no way to directly relate grams of CH4 to grams of H2O directly. There's no way to do that. That's what the chemical equation does. Chemical equation is like a recipe. So if I gave you 100 pounds of flour and 200 eggs and 300 cups of sugar and told you to go bake 100 cakes, well, you'd have the ingredients, but you wouldn't know what to do because you don't have a recipe. Until you have a recipe, you won't know how to mix the eggs and the flour and the sugar. Well, it's the same thing here. This is the recipe for taking CH4 and O2 and producing CO2 and water. And so it's a recipe. So you need to go into the recipe to make this conversion from CH4 to H2O. So it's 3 steps. Here's the first step. Use the molar mass to get moles of C2H4. Now you go across the equation from C2H4, moles of C2H4 to moles of H2O, and that puts you in this box right here. That's the second step. Now you go from moles of H2O using this molar mass conversion to grams of H2O, and that's what the question is asking you for. So if I drew that with arrows, this goes to here, then across we go over to here, and then from here we come down, back out, and end up there. So that's 1, 2, 3 steps to get there. All right. So let's go ahead and write down what we have here. So we have how many grams of H2O. So way over here on the right, and I mean way over there because it's going to be a long equation. It's grams H2O. And that's what you're looking for, that. And you're starting off with 5.2 grams of C2H4. So I'm going to start that way over here on the right. And then I'm going to need 3 conversions. The first one going from grams of C2H4 to moles of C2H4. The second one going from moles of C2H4 to moles of H2O. And the third one going from moles of H2O to grams of H2O. All right, so let's look at the 2 conversions we have going in here. We have the molar mass conversion. So that means it's 1 mole Okay, so you can take this and put mole over gram, gram over mole. So 1 mole of C2H4 for every 28 grams of C2H4. It's also equally true statement to say 28 grams of C2H4 for every 1 mole of C2H4. So which one of these 2 do we want to put here? Think about that. Remember the principle. Okay, and the answer is we want to get grams of C2H4 to cancel out because that doesn't end up in our final answer. So it needs to go away. So we're going to pick the one that has grams of C2H4 on the bottom. That would be this one. Okay, so there's our first conversion. Now we're inside this box right here. Now we need to go from this box to this box. So there's 1 mole. The relationship is 1 mole of C2H4 is equal to 2 moles of H2O. So let's go ahead and write that out as 2 ratios. So this is the time when you use these coefficients right here. That and that. Okay. So now we have one of these 2 ratios goes in here. Which one is it going to be? Well, here let's cancel this. We've already done that. Here you have moles of C2H4, but that doesn't appear in your final answer. That means it has to go away. So we need to pick the one that makes moles of C2H4 cancel out. Which one is that? That's this one. Okay, and moles of C2H4 cancels with moles of C2H4. Now we've got 1 more left. We're now sitting in this box and we want to get out here to the question mark, our final answer. So we use this molar mass conversion. So let's write the ratios for that. Okay, and so what we need to do is make moles of H2O cancel out and grams of H2O appear in the final answer on the top. So the one we're going to use is this one right here. Okay. Okay, so moles of H2O cancels there and there. The only thing we have left is grams of H2O, which is what we want for our final answer. So that means we have all the numbers lined up properly. So now what you're going to do is you're going to say 5.2 times 1 times 2 times 18 divided by 1 divided by 1 divided by 28, and that will be your final answer. And that gives us a number of 6.7 grams. So if you ran a reaction with 5.2 grams of ethylene, C2H4, and enough oxygen so that you didn't run out of oxygen, that's important, you'll end up with 6.7 grams of water from that reaction. Okay, so that's how you do these. They're just the same as what we've been doing the last 2 days, but they're all going to have 3 steps or 3 boxes or 3 conversions in them. Okay, we're going to go from grams to grams in all of them. Okay, let's move on to the next one. I'll try to keep everything on the screen here. It's going to be a little bit hard. Okay, let me erase first of all this. All right, so it says how many grams of CO2 will be produced by 4.3 grams of C2H4. Okay, so it's asking for how many grams of CO2. So way over here on the right, we have grams. So you have your unit of measure, whether it's grams or moles, and what substance you're talking about. You got to be sure to have both of those. Otherwise, it's very easy to get confused in one of these problems. Okay, and we're starting off with 4.3 grams of C2H4. So way over on the left. Okay, so 4.3 grams of C2H4, 4.3 goes right there. and we're looking for grams of CO2. So here's CO2, here's the grams. So it's a similar path to the last problem. We need to go from what we know, and that's grams of C2H4, using molar mass to get moles of C2H4. We can only move sideways inside the chemical equation because that's the one that gives us our recipe, our relationships between these. So once we have that, that's the first conversion. We move from here over to here, moles of C2H4 to moles of CO2. That's our second conversion. And then from there, we come back out of the equation to our final answer using the molar mass of CO2. So that's 3 steps. So if I can just redraw this one arrow right here. So it comes down here. And then we draw this down like that. So up here, over here, down here. Okay? So go ahead and see if you can lay that out. I'm going to do it silently. And I'll try to keep everything on the screen as best as I can. And I'm going to do it silently. You go ahead and see if you can work it on your own, okay? And then I'll explain it when we're both done. Okay, so what we did was we started with what we knew, 4.3 grams. We have to use the molar mass conversion. 1 mole is 28 grams of C2H4 to get into moles. So we use the one that causes grams of C2H4 to cancel out, choosing between these two. Now we're ready to go from here to here. That's moles of C2H4 to moles of H2O. It's a 2-to-1 relationship you see there. So 2 moles of 2 moles of CO2 for 1 mole of C2H4, still 2-to-1. And so you put the 2 moles of CO2 on top of moles of C2H4, or the other way around. Which one do you want? Well, you need moles of C2H4 to cancel out, because that doesn't end up in your final answer. So that means you need it on the bottom. So you took 2 moles of CO2 over 1 mole of C2H4 goes in here. That makes the moles of C2H4 cancel out. And that puts you right there. Now you need to come out of the equation. I keep pointing to water. It's CO2. You come out of the equation from CO2 moles to grams of CO2 using this molar mass right here. Okay. So I have 1 mole of CO2 for every 44 grams, or 44 grams for every 1 mole. Those are both true statements. But which one do I want in the equation? I want the one with moles of CO2 on the bottom because it needs to cancel there. So I put this one right there. So moles of CO2 canceled. The last man standing is grams of CO2, which is what I want because that's the units of my final answer. And then what you do is you multiply 4.3 times 1 times 2 times 44, everything on the top. Then you divide by everything on the bottom. Divided by 1, divided by 1, divided by 28, and that will give you your final answer right there. Okay, so let's move on. How many grams of O2 is required to produce 8.3 grams of CO2? Okay. So here's our graphic organizer. We're talking about how many grams of O2. So we find O2, here's grams, and it wants to know how many. That's the question mark. And what do we want to produce? 8.3 grams of CO2. Okay, so let's go ahead and erase these arrows here. Okay, so we're going to start here and we need to end up here. So even though the chemical reaction is going from left to right, it's going from reactants over here to products, our math equation is going in the other direction. Because we're already given a certain number of grams of a product, and we want to know how many grams of a reactant it will take to give us that. So what we do is we go from grams of CO2, we go up to moles of CO2, then from moles of CO2 over to moles of O2 inside of the equation. You can only move sideways inside of the equation. And then finally from moles of O2 down to grams of O2. So 3 steps again. All right. So let's go ahead and do that. So the first one is going to be grams of CO2 to moles of CO2 using the molar mass of 1 mole for every 44 grams. So let's go ahead and write that out. Let's start by writing out the equation. Okay, and the first molar mass is the CO2 to moles of CO2 using the molar mass. Okay, so again to review is we started with 8.3 grams of CO2 right here. We needed the molar mass conversion. 1 mole is 44 grams. So we needed the one that made grams cancel out, grams here cancel out there. So now we're sitting in moles of CO2 right there in that box. Now we need to go from 2 moles of CO2, equate 2 moles of CO2 to 3 moles of O2. So you can put those two ratios in both order. And which one do you need? You need moles of CO2 to cancel out. So you're going to use this one. So it's 3 moles of O2 over 2 moles of CO2. That cancels with that. Now you're sitting here with moles of O2. You need that to cancel out and get grams of O2. So now we're ready to come out. Use the molar mass conversion, 1 mole per 32 grams. So there it is right there, written both ways. You need the one with grams on the top and moles on the bottom to cancel out. So moles of O2 cancels with moles of O2. Grams of O2 comes over here. Gives you that. So now the multiplication is 8.3, everything on the top. 8.3 times 1 times 3 times 32, and then divide by everything on the bottom. Divide by 1, divide by 2, divide by 44, and that gives you 9.1 grams. Okay? All right. I'm going to go ahead and just do the next one. It's just going to appear magically, and then I want you to do, that's D, and then I want you to do E on your own. Okay, so there it is. It just magically appeared. So you start off with 5.6 grams of H2O. So let's go ahead and do that. So you have 5.6 grams here. And it's asking how many grams of O2, so we still have a question mark there. So you're going to have to go from 5.6 grams of H2O into moles of H2O using this molar mass. So there it is right there, molar mass of water. Now you have moles of H2O right here. You need to relate moles of H2O to moles of O2. So 2 moles of H2O equals 3 moles of O2. So that's going to give you 2 ratios down here. and the one you want to pick is the one that gives you 2 moles of H2O on the bottom, because that'll cancel with this. I didn't draw the lines here because I want you to be able to see clearly what I have. And now you're in moles of O2, and you need to get out and get into grams of O2 for your final answer, so you need to use this molar mass. 1 mole over 32 grams, or 32 grams over 1 mole. So there, those two are right there. And the one you pick is 32 grams over 1 mole, because you need grams to end up in your final answer, and you need moles of O2 to cancel. So you can see the cancellations happen, and the only thing you have left is this one. So it's 5.67 times 1 times 3 times 32 divided by 1 divided by 2 divided by 18, and that will give you your answer. Okay, I'm going to leave this last one for you to do. Just follow the same pattern, and hopefully it's not too difficult. And we'll have one more lesson this week tomorrow on Thursday, and you can I'll have that up fairly soon, maybe later today, Wednesday. Okay, have a good day. Take care of yourself. Take care of your family. Most important things are your family and you and your health. So take care. Have a good day.